It's an online class, and I've never met any of my classmates, so it'd be cool to introduce myself. Hey, how's it going, guys? My name is Andy Trevino. Today we're going to be talking about big data and climate change. We've all heard the terms global warming and climate change. Essentially, global warming happens when greenhouse gases are emitted with enough concentration that heat becomes trapped close to the surface of the planet. In the absence of greenhouse gases, some of that heat would be released into the atmosphere. Over time, the average global temperature rises to the point that we see significant differences in, among other things, temperature, weather patterns, animal migration and populations, and food and water resources. The combination of these effects are collectively known as climate change. While the Intergovernmental Panel on Climate Change, the IPCC, reports that 97% of climate scientists agree that climate change is happening and that climate change is caused by human activity, there is a culture of people who are in a very powerful denial about this. This culture of deniers is referred to collectively as the climate deniers. The majority of climate deniers do not believe that climate change is being caused by human behavior. What's worse, there's a small subculture who believes that climate change is not happening at all. Why is there so much debate around the causes of climate change? More so, why is there a debate over the existence of climate change altogether? Among other things, this is partly a sociopolitical question, partly an epistemological question, and partly a scientific question. The sociopolitical piece of this issue is the most obvious. Obviously, the majority of people get their information from the most popular media sources. Those 5 main media sources are owned by an elite few. These elite few serve both on the boards of the media companies they own, as well as other businesses. There is an obvious and apparent conflict of interest here. Of course, the owner of a media company would not want stories about his or his partner's business aired that would show their business in a harmful way. This conundrum is clear. At best, we can try to make people more media literate to combat this. To try to get more regulations passed to prevent this from happening altogether seems futile. The former seems more pragmatic. The epistemic and scientific aspects of the question, why there is such wide debate over climate change, are very closely related. This seems obvious. Epistemology is the study of what we know, how we know it, and how much we can know. Science is in the business of helping us know more through empirical study. The former is a more subjective approach to knowing, the latter is more objective. Science discovers truths via data collected. Enter big data. The idea of big data refers not merely to the size of data itself, but more so to the rate at which data can be analyzed, processed, and given meaning. However, at the most basic level, big data is a collection of data points. At best, these data points allow us to observe correlational relationships. However, just as we should not confuse correlation with causality, the converse is equally true. We should not liken correlation to a lack of evidence. Correlation is the skeleton, the framework, the backbone to the scientific method. Both correlation and scientific method are dynamic in that they both are willing to change as a result of new and contradictory evidence. However, this does not negate their efficacy. For example, the general theory of relativity, which is commonly thought of as gravitation or gravity. Gravity is not directly observed, however, we see correlations of its existence all around us. Trusting in the theory of gravity has enabled some amazing technological advances. For example, the airplane. We had to have a complete trust in the effects of gravity to achieve flight. In other words, if we didn't trust the existence of gravity enough to treat it as a constant in the formula of flight, then there would be no flight, for humans at least. I mentioned correlation here because big data can offer a lot in regard to our study of climate change. While the study of climate change often results in correlational relationships, we should understand that correlation is not necessarily a result of a lack of data. This is important to keep in mind as we look at a few examples of how big data can help us understand the effects of global warming. Climate science, or climatology, can be thought of as the study of weather conditions over a specified time. This can include, but is not limited to, atmospheric sciences, physical geography, oceanography, and biochemistry. Oftentimes, prehistorical climate patterns are brought up in arguments over the existence and causes of climate change. For example, a common argument against the existence of global warming might sound like this. Weather patterns have varied throughout the history of the planet. What we are experiencing is a natural phenomenon and not different than what has always happened on the planet. That statement is not completely accurate. It is true that the planet has experienced climate fluctuations. However, a paleoclimatologist might argue that the climate fluctuations we are seeing today have never happened so quickly, frequently, or to the magnitude we are seeing. Paleoclimatologists base their knowledge of prehistorical climate changes based on evidence from ice core samples and tree ring samples. Climate science is based on hard empirical evidence. Often the climate denial camp does not grant an appropriate amount of credit for the science that happens behind the scenes of climate science. Considering the number of contemporary scientific fields of study involved in climate science, and considering the amount of data that must be examined to make predictions on the effects of global warming, you can imagine the amount of data that must be collected, processed, and analyzed. For example, being able to make accurate predictions about geographical changes would entail massive amounts of data and processing capacity. Google Earth Engine is a great example of how big data can help with studying and making predictions about the effects of global warming. According to their website, Google Earth brings together trillions of scientific measurements from the past 40 years. The Google Earth Engine helps provide data for detecting deforestation, classifying land cover, estimating biomass and carbon, and among other things. Another example of how big data can help with the study and predictions of the effects of global warming is in regards to changes in biological organisms across the planet. The scientists at Microsoft Research have developed what's referred to as the Mattingly model. It is the world's first general ecosystem model. According to their website, the model is the first to couple all of the key biological processes that underpin the life cycle and behavior of all of the millions of trillions of the planet's organisms, which would include photosynthesis, feeding, metabolism, reproduction, dispersal, and death, in order to attempt to capture how such processes lead to the structure and function of the whole ecosystem. In this way, the model addresses the central questions in ecology. How do interactions among plants and animals lead to the ecosystems that we see around us? How do these ecosystems vary across the world? What will happen to these ecosystems in the future in response to various human pressures? And how can we mitigate or reverse any damage? This model is basically a huge computer simulation of all life on planet Earth. This model is a great example of big data, due one to the amount of data that is processed, but also the speed at which it needs to be processed so that we can make accurate predictions about the effects of global warming and what actions we can take to slow that down or reverse it. Being able to study and predict effects of global warming on a global scale is extremely important for the scientific community. However, being able to use big data to illustrate examples of local effects of global warming is extremely important as well. Generally, when people are exposed to local environmental issues, they are more likely to relate to the issue and, as a result, are more likely to take action to improve that issue. The willingness to make changes to improve environmental issues is commonly thought of as climate action. Lakes Travis and Buchanan supply water for the Austin area, which includes more than 1 million people as well as businesses and agriculture. The lakes are currently at 38% of the normal levels. Just to monitor the activity on Lake Travis, the Lower Colorado River Authority receives data from 15 water monitoring sites every 15 minutes and displays this information on their website in real time. Each monitoring site provides several different measures including water levels, flow rates, and water quality data. This amount of data would certainly be considered big data, especially considering the time at which it needs to be processed and analyzed. The monitoring of Lakes Travis and Buchanan by the Lower Colorado River Authority is a great example of how big data can be used to demonstrate environmental issues on a local scale. I've given a brief introduction to climate science, and we've talked about a few examples of how big data can be used to promote climate action in general, and seen a local example of how big data is being used today for a local environmental issue. For me, I've discovered that framing climate issues in a local framework or context is crucial for people to really relate to that issue and accept the issue, and also for them to make people feel like they want to make changes in their lives to live a more green or sustainable lifestyle. I'd like to thank Max Anderson for filming this for me, and also if you want to check out his blog, it is mandersonfilm.wordpress.com, and I would also like to thank Arrowhead Films for providing the equipment for this.